This is part 2 of 2 showing how I made a ratchet wrench into a lever for a 3-ton Arbour press. I could have simply machined a hexagon on the end of the pinion shaft. I also machined a cap to hold the wrench on. During this second stage of machining, I'm using an 8mm carbide end mill and a tool path which cuts the 12-point feature on the end of this pinion shaft. I hand coded this tool path as I was having problems with the Fusion 360 post-processor. I don't know what the problem is still. Fortunately, there was a lot of repetitive coding which I was able to copy and paste. The total depth of cut was around 22mm. I only took half at a time. I had the spindle speed set to 2000 RPM. My roughing cuts were just half a millimetre step over, and my final cut was 0.3 of a millimetre step over. With an 8mm tool, the offset of the finishing cut needed to be 4mm. The offset of the last roughing cut was at 4.3mm. So I coded roughing cuts at 4.8, 5.3, 5.8 and 6.3. Fortunately, with a 12-point pattern, the numbers repeat every 45 degrees, making the coding easy. When it's a one-off project, getting the speeds and feeds right are just a matter of trial and error and seeing how things sound and seeing how the vibrations come through and the chips that are coming off the tool when it's cutting. Scott Morrison would say it's not a race, it's a good day when you finish a job and you haven't broken a carbide tool. My tool path is just a series of straight lines. The inside corner is relieved by the drilled hole that was done in part 1. At this stage, the top half of the feature has machined correctly, and we're now working at full depth, which is 22mm. The feed rate is set to 100mm per minute, so it's taking over a minute to do a lap of the 42mm cylinder, somewhere around a minute 30. I was not game to try machining with the full 22mm depth of cut and a larger step over and a higher feed rate. Maybe it would have worked, but I'm worried about the cost of carbide. When I speed up the video, the machining starts to look like it's being done on a professional machine in a production tile run, but bear in mind that spindle would be running effectively at 8000 RPM, moving at 400mm per minute, and yeah, it's tearing off material at a good rate of knots. This is back to normal speed, and we're about to start the finishing cut. You can see that the Z distance of -22 is the depth of cut. The 4mm offset comment has just clicked past there, so we're only taking 0.3 of a millimetre step over at this point. So we're on the final lap of the pinion shaft. The final shape of the facets of the 12-point feature are starting to appear. There's 24 of them as you go round the full circle. The final instructions of this 4mm offset tool path are being executed, and we will be finishing shortly. The tool withdraws and retracts and returns to the origin at 0, 0, which is the center of the column, to finish the process. A quick blow off with compressed air. This is the ratchet spanner it's got to fit. That spanner flops around a bit. Most of that movement's in the ratchet mechanism itself. The actual nut fits pretty well. I'm not going to remake it, so it's going to do what it is. As I said at the start, a simple hexagon would have done this job, but doesn't this look pretty? And it's been a challenging exercise. The part one was all about drilling all of those holes because it wasn't going to work without them. I'm really happy and satisfied with that. So get out to your shed and make something that's fun.